This clip discusses display attributes, that is, how we specify displays. The main attributes we'll discuss here include resolution, pixel density, which is not the same as resolution, the refresh rate, color depth, color gamut, and a few other attributes that might be important when deciding between one monitor and another. Now, resolution is simply the ability of a display to show X number of dots or pixels in the horizontal dimension times Y number of pixels in the vertical dimension. Most modern displays can work at varying resolutions, but only one, the so-called native resolution, shows the display at its best. Here's a table showing some common display resolutions over the past several years. Many of these resolutions have a name that's used in the TV industry, such as 4K, as well as a nickname in the computer world, such as QHD or Retina, an Apple name that actually applies to multiple different Apple product resolutions. You don't have to memorize all these for the A+ exam, but you should know the more common ones, which I've labeled in purple. Be aware that many laptops can support a higher resolution on an external display than they can on their built-in display. For example, our demo HP EliteBook has a resolution of 1920 by 1080 for the built-in display, but can go to double quad HD or 5120 by 1440 on an external display. Now in Windows, we can change the resolution using the Settings applet. The native resolution appears with the word recommended, as you can see here on my desktop PC. On a MacBook, we open the System Settings window, but if we can't select the resolution directly for the internal display, we can choose the Scaled button and choose from some preset zoom levels that emulate different resolutions. There are free apps, such as EasyRes, that allow us to change resolution values directly. On a mobile device, we can set the resolution differently for the internal display and any external displays that we may be using. Often confused with resolution is the term pixel density. Now, pixel density means how many pixels, or discrete image dots, there are in a given linear unit, such as an inch. The greater the pixel density, the greater the perceived detail. Now, to avoid confusion, remember that resolution doesn't care about the distance between pixels, just how many of them there are in total. You could have two displays with the same resolution, but if one was twice as large as the other, its pixel density would be half of the smaller ones. Now, another term you'll see is refresh rate, which is how many times the display controller redraws the display every second. 60 Hz means 60 times per second. Larger numbers can give the display a more rock-solid feeling, but you may not notice it unless you're working with video. Almost all displays can run at a 60 Hz refresh rate, but modern displays can go all the way up into the hundreds of hertz, although the law of diminishing returns does apply here. Now in Windows, regardless of version, we can change the refresh rate by opening the Properties page of the display adapter and clicking the List All Modes button to see the possibilities. In the Mac OS, the method depends on which version of the operating system we're using, but as an example, on this computer we need to hold down the Option key in the Display Preferences window and choose the Scaled button to see our choices for refresh rate. As with resolution, we can set the refresh rate independently for internal and external displays. Speaking of external displays, here's what the Project menu looks like in Windows 11. We can usually get here using a function key or a function key combination. The projection choices include internal display only, clone or duplicate the internal display to an externally connected display, extend the virtual display across both monitors, and limit the display to the external screen only. These options are useful when a user is making a presentation with a laptop. Just be aware that certain applications, such as PowerPoint, will automatically display different content on the internal and external displays. Now, dealing with external displays on a Mac laptop is a little different, but the concepts are similar. You just navigate to the Apple menu, choose System Settings, and then select Display. The Arrangement tab lets you drag and drop the displays in the extended arrangement you prefer. The placement of the white menu bar denotes the primary display, and you can drag and drop the menu bar to the other display if you want to make that the primary one. If, however, you click on the box labeled Mirror Displays, then you'll see the graphic change to look like this, in which case the external display shows the same content as the internal one. By the way, the AirPlay Display option would be useful to project the Mac's display to an Apple TV connected to the same Wi-Fi network as the Mac. Well, two more terms have to do with display color. Color depth is how many bits per pixel are available for conveying color information. The modern convention is for this number to represent the number of bits per pixel per color. So, for example, if n is the color depth per pixel, the total number of possible colors would be 2 raised to the nth power, and then take that number and cube it. So 8-bit color gives us about 17 million possible colors, and 10-bit color is over 1 billion, which is way more than the human eye can even see. Now our last term is color gamut, and this just means the range of visible colors that a given combination of display controller and monitor can show us. This is typically expressed as a percentage of a standardized color range, such as sRGB, Adobe RGB, and so on. When comparing displays, make sure the percentage value quoted is for the same standardized color space. Here's a chromaticity diagram, a pictorial view of the boundaries of different color spaces that are commonly used for defining display capabilities. The tongue-shaped area bounded by the white outline defines the color space visible to the average person. Colors appear more saturated as you approach the edges of the tongue. Now, there are several miscellaneous display attributes that may be important in particular situations, so we'll touch on those briefly here. Connectivity, not normally an issue, but it's convenient when your display can talk with your computer without needing an adapter cable. Wide screens look better when curved, as we know from movie theaters. In areas with high ambient light, an anti-glare coating can make a difference, as can an auto-sensing dimmer circuit. Graphics professionals can fine-tune their displays with color profiles that the operating system uses to tailor video output. So just to illustrate, here's my own monitor's connectivity panel with HDMI, DisplayPort, audio, and USB support. I don't use the audio connectivity because most computer displays have terrible built-in speakers. And here's the same monitor's double quad HD display, which you can see from the top view is curved for easier viewing. Finally, I can set the color profile via the Properties page for my graphics card in Windows 11. Clicking the Color Management button lets me specify different profiles for different use scenarios, and there's even a cool Calibrate Display button that walks me through a series of screens to optimize the display. And that's a quick look at computer displays.